Okay, ladies and gentlemen of geometry, this is kind of taking a little bit step back to algebra days, talking about solving systems of equations, which does come up a little bit when you are talking about geometry. So just a quick refresh. So a couple different ways you can solve systems by substitution, or you can solve it by elimination, or come talk to me and I'll show you how to do it on a graphic calculator. So back there was your steps, how to substitute them before. Take a minute, write them down. One or two things can happen if everything cancels out and you're left with what's called a mathematical truth. That's going to be infinitely many solutions. And if you come up with something that's always false, that's going to be no solution. So here we start. So y equals -10. That makes life really easy because all I need to do now is write, instead of y, I'm going to put -10. Now there's only one variable. I can solve for that very easily. (10x = 30). So x is going to equal 3. That's my answer. So now I know that x is 3. I know y is -10. So my solution is just going to be 3, -10. Answer. Make sure you solve for both. So now this gets a little bit trickier because I've got y equals 2x plus 3, but it's still the same idea. I'm just going to substitute this in exactly for y. So instead of 5y, I'm going to make sure it's -5 times 2x plus 3. Now I've got to distribute this, but I've got to bring the sign with me. So it's going to be -10x minus 15. Number one mistake kids make is that they will put a plus there. So now combine like terms, that becomes 5x. 5x equals 45. So x is going to equal 9. X equals 9. Throw it back in here. You get y equals 2 times 9 plus 3. So y is going to equal 21. So my solution here is going to be 921. So solving systems by elimination. By elimination means you technically eliminate one of the variables. So get rid of one completely. Then go back and figure out. What the variable is. So get rid of one, solve for the other one, then go back and figure out what the first one was, the one you eliminated. So the deal is you've got to get the same thing of both of them. So here you've got to get this kind of situation where you've got positive 5y, negative 5y. Because if I add these two things, I should get 7x. This goes away. It's going to equal 14. So a little algebra, x equals 2, not 7, 2. So then put this back into one of these, I don't care which. And that's going to give me what y is. -5y equals -2. Hey, you know what? That's plus 5y. 4x plus 5y equals 6. Yep. So it's going to be -2/5. There's my answer. Now here I don't have that matched up, but I can match it up pretty easily. So probably a good thing to do. I've already got the negative and positive with y's. So I'm just going to multiply whatever in front of the other one. So 3x minus 4y equals 10. I'm going to multiply this top one by 7. And that's going to give me 21x minus 28y equals 8. I'm going to multiply this bottom one by 4 because that's what's in front of the y up here. So I'm going to get 20x plus 28y equals 12. So now when I add these two things together, I'm going to get 41x. It doesn't show up very well. Let's just go 0.8. 41x. This becomes 0 equals 82. So divide by 41. X equals 2. Now go back and substitute that in and solve it. And I don't care where you substitute it back in. You can substitute in here, here, or the ones you calculated, or the ones you multiplied by. So go 3 times 2 minus 4y equals 10. So 6 minus 4y equals 10. So negative 4y equals 4. So y should probably be negative 1. So my solution there is going to be 2, negative 1. So find P and Q such that this is a parallelogram. So in order to be a parallelogram, this has got to be equal to this, and this has got to be equal to this. So I get 2P plus 3Q equals 18. 5P minus Q equals 11. So now, since I've already got a plus and a minus here, I'm going to multiply this by 3. So I'm going to keep the top one as is. Bottom one's going to become 15P minus 3Q equals 33. So when I add these two, this becomes 17P, this becomes 0, this becomes 51. So a little division, P is going to equal 3. So P equals 3, substitute that back in somewhere. So I'm going to go, I'll take this one, 2 times 3 plus 3Q equals 18. And now it's just algebra problems, straight algebra, like you've been solving for a long time. Change colors, you're going on the white, 3Q equals 12, Q is equal to 4. There's your answer. Now, one kind of short way to do this, I'll show you how to do it on your calculator, is if you take the system, take the original that we had, show you kind of just, this is if you got a graphing calculator, or I'm going to show you how to do it. It'll save you lots of headaches. It's called matrix operations, and it's a nice slick way to do this. So if I just take the numbers, so just take 2, 3, 5, negative 1, and multiply that times P and Q, and that's going to be equal to 18. So now, what's the point of algebra? We always want to get the variable by itself. So if only there was some way we could have like this. P and Q is equal to something. Well, the trick is we can do that by taking what's called the inverse. So now if I can take the inverse, it essentially moves this over to the other side. This is called a matrix. So I move it over to the other side. I take what's called the inverse. That's what the negative 1 is there for. And I multiply times 18 over 11. Now, you don't do this by hand. You let the calculator do it. But you should get the same answers that you did by either using substitution or elimination. Again, come show me. Say, Mr. Heeren, show me that trick on the calculator to do systems, and I will gladly show you. All right. Thank you very much. Come talk to me with questions. Good night.